Good day to all. In this video lecture, let me discuss about the steps and the problems based on theoretical air calculation on weight and volume basis. We should follow certain steps before solving the problems. Now we'll look into the steps. Number 1. Amount of oxygen required by the fuel will be given by subtracting the amount of oxygen already present in the fuel from the theoretical amount of oxygen required by the fuel. The air contains 21% of oxygen by volume and 23% of oxygen by weight. Hence, the minimum weight of air required is given as 100 by 23 into minimum oxygen required, and minimum volume of air required is given as 100 by 21 into minimum oxygen required. Number 3. The molecular mass of air is taken as 28.94 grams per mole. The density of air at NTP is 1.29 kilogram per meter cube. Number 5. 22.4 liters of any gas at NTP has a mass equal to its 1 mole, that is gram molecular weight. 22.4 liters of carbon dioxide at NTP will have a mass of 44 grams. The molecular weight of carbon dioxide is 44. This is for an example. And number 6. Excess amount of air is necessary than the theoretical amount of air to achieve the complete combustion. This excess air required is expressed in percentage of the theoretical air as theoretical air into 100 plus excess air divided by 100. The amount of air required for complete combustion of a fuel can be calculated by following the various steps as given below. Step 1. Write the equation for the combustion reaction. Step 2. From the equation, calculate the amount of oxygen required for the elements present in the fuel. Step 3. If oxygen is mentioned in the problem, subtract the weight or volume of oxygen already present in the fuel from the total weight or volume of oxygen required by the other elements. Step 4. Since nitrogen, carbon dioxide and water vapor are non-combustible, they do not require any oxygen or air. Therefore, their values, which is mentioned in the problem, can be ignored. Step 5. Finally, calculate the amount of air required by the fuel by multiplying 100 by 21 if volume percent and 100 by 23 if weight percent is given with total amount of oxygen required. Step 6. Excess amount of air is necessary than the theoretical amount of air to complete or to achieve the complete combustion. This excess air required is expressed in percentage of theoretical air as theoretical air into 100 plus excess air divided by 100. We'll look into the problems now. Problem number 1. What is the volume of air required for the complete combustion of 1 meter cube of mixture containing 80% of methane and 20% of ethane? Now, we'll write down the combustion reaction. Methane with oxygen forms carbon dioxide and water. Balance the equation so that we can arrive that 1 volume of methane require 2 volume of oxygen. Similarly, ethane with oxygen forms carbon dioxide and water. Balance the equation and we can arrive at the volume as 1 volume of ethane require 3.5 volume of oxygen. Now we'll write on the formula as 100 by 21 into 2 of methane plus 3.5 of ethane minus oxygen. We have considered here only the methane and ethane since in the problem we have these constituents alone. And here 100 by 21 denotes The volume of air required, how much? 21% of a volume of oxygen. And 2 of methane denotes that 1 volume of methane require 2 volumes of oxygen. Similarly, 1 volume of ethane require 3.5 volume of oxygen. So we can write like this. And you can substitute the percentage of methane and ethane as, since 80% is given, it can be written as 0.8 for methane, and for ethane it is 20%, and hence it is given as 0.2. And oxygen is not mentioned in the problem, and hence it is denoted as 0. Upon substituting, we get a final answer as 10.95 meter cube. Problem number 2. Calculate the minimum volume of air required for the complete combustion of 1 meter cube of a gaseous fuel containing carbon monoxide 23%, hydrogen 12%, methane 3%, carbon dioxide 5%, nitrogen 55%, and oxygen 2%. So in this problem, we can ignore carbon dioxide and nitrogen. Now we'll write down the combustion reaction first. Carbon monoxide with oxygen forms carbon dioxide. Balance the equation. We arrive that 1 volume of carbon monoxide require 0.5 volume of oxygen. Hydrogen with oxygen forms water. Balance the equation, and hence 1 volume of hydrogen require 0.5 volume of oxygen. Methane with oxygen forms carbon dioxide and water. Balance the equation. Then we can write 1 volume of methane require 2 volume of oxygen. So we can compare. For 1 volume of carbon monoxide require 0.5 volume of oxygen. Then what is the percentage of carbon monoxide given? So just cross multiply. Now we can write on the formula. We can write the formula as 100 by 21 into 0.5 of carbon monoxide plus 0.5 of hydrogen plus 2 of methane minus oxygen. Substitute the percentage given. Carbon monoxide 23% can be written as 0.23. Hydrogen 12% can be written as 0.12. Methane 5% can be written as 0.05, and the oxygen is given as 2% and it's substituted as 0.02. Finally, we arrive at the answer as 1.02 meter cube. Till now we have discussed the gaseous fuel. Now we'll look into the solid fuel. So now in this problem we are going to discuss about the weight of oxygen required. Problem number 3. A fuel contains carbon 75%, hydrogen 4%, sulfur 7%, oxygen 5%, and the remaining ash. Calculate the minimum quantity of air required for the complete combustion of 1 kilogram of fuel. We'll write down the combustion reaction. Carbon with oxygen forms carbon dioxide. The weight of carbon is 12 grams. The weight of oxygen is 32 grams, which means 12 grams of carbon require 32 grams of oxygen by weight. You can calculate the same for the percentage given in the problem. Just cross multiply. So similarly, we can substitute in the formula as 32 by 12 into carbon, as we have done for the gaseous fuel. Hydrogen with oxygen forms water. Balance the equation. The weight of hydrogen is 1 gram. Oxygen is 16 grams. So 1 weight of hydrogen required. What's the weight? 16 grams of oxygen by weight. Sulfur with oxygen forms sulfur dioxide. The weight of sulfur and oxygen is 32. So now we can write down the formula as 100 by 23, since R requires 23% of oxygen by weight, into 32 by 12 into carbon plus 8 hydrogen plus 1 sulfur minus oxygen. Now we'll substitute the percentages given for the constituents given in the problem. Carbon 75 can be written as 0.75, hydrogen 4%, write as 0.04, sulfur 7%, write as 0.07. Now oxygen is given as 5%, substitute as 0.05. So finally we arrive at the answer 10.174 kilograms. Problem number 4. A coal sample was found to contain the following: carbon 90%, hydrogen 6%, sulfur 2.5%, oxygen 1%, nitrogen 0.3%, and the remaining ash. Calculate the quantity of minimum air required for the complete combustion of 1 kilogram of coal sample if 25% of excess air is used. So apart from calculating the theoretical amount of air, we are supposed to calculate the excess air in this problem. Write down the combustion reaction. Carbon with oxygen forms carbon dioxide. Hydrogen with oxygen forms water. Sulfur with oxygen forms sulfur dioxide. Balance the equation, and finally we can write down the formula as 100 by 23 into 32 by 12 into carbon plus 8 into hydrogen plus 1 into sulfur minus oxygen. Substitute the percentage given as in the problem. Carbon 90%, it's written as 0.9. Hydrogen 6%, it's written as 0.06. Sulfur 2.5%, write as 0.2025, and oxygen 1%, it's written as 0.01. So finally we arrive at the answer 12.58 kilograms of air. So this is a theoretical air calculation. So now we have to proceed with the excess air. For excess air calculation, the formula is theoretical air into 100 plus excess air divided by 100. The value for theoretical air is 12.58 and the excess air is 25%. Substitute the percentage as such for excess air. So 12.58 divided by 100 into 100 plus 25. So finally we arrive at the answer 15.725 kilograms of air. As a recap, for solving the theoretical air calculation problems, first step, write down the combustion reaction. Balance the equation. Then write the weight or volume of oxygen required. If weight is considered, you can write down the formula as 100 by 23 into 32 by 12 into carbon plus 8 of hydrogen plus 1 of sulfur minus oxygen. For gaseous fuel, you can consider what are the constituents given: methane, ethane, carbon monoxide, hydrogen. And if carbon dioxide, water and nitrogen is given, kindly ignore the values given. Similarly, if oxygen value is not mentioned in the problem, substitute the value of oxygen as 0. And for excess air calculation, need not convert the percentage, substitute the percentage as such for excess air. If 25% is given, substitute as 25. And for the rest of the constituents, convert the percentage. Thank you for watching this video lecture.